Okay, this equation says cosecant squared minus 2 cotangent equals 0. Pretty straightforward, doesn't seem too complicated. But you'll notice you can't find any greatest common factor. You can't factor this like a trinomial. There's no factoring we can do with it in its current form because these are different trig functions. Okay, and that's just giving us some problems. So we're reaching for an identity of some kind, and when it comes to choosing the identity, I usually say, hey, because that angle right there is not a double angle, we can avoid the double angle identities, right? We could just sort of ignore those. Now, that's not a rule. It's just a hint. I would probably reach for the Pythagorean identities for this one. In particular, the cottage cheese identity. Cottage cheese looks like it's going to be a big help here because that has cotangent squared and cosecant squared. And I see a cosecant squared right there. So that is one technique. It is not the only way to solve this thing. And I'll just make the cottage cheese substitution so you can see how that would work. And then I'm going to get into how you would use a double angle on this thing. So cottage cheese identity says, if we make this substitution, 1 plus cotangent squared omega minus, okay, so that's cosecant squared, minus 2 cotangent of omega equals 0. And that just means cotangent squared of omega minus 2 cotangent of omega plus 1 equals 0. So great. And if you want to go on and factor that, you can find some solutions and that'll be fine. Now, what I want to do instead, actually, is this going to work? Yeah, this is going to work just fine. So you could solve this by factoring. What I want to do instead is show you how to do this with double angles and quotient identities, just to show you that you can, so you can gain a little more confidence in not making the wrong decision up top and everything being hopeless after that. So let's try using a quotient identity on here and rewriting this thing as 1 over sine squared omega, that's cosecant squared, minus 2 cosine omega over sine omega equals 0. Well, what does that say? That says a bunch of fractions, and maybe let's get rid of the sine squareds on the bottom by multiplying the whole equation by sine squared. So this becomes 1 minus, okay, that crosses out. And then one of the sines crosses out, but we have a sine left over. So this becomes 2 times sine omega cosine omega equals 0. And now we have, well, we basically have this. 1 equals 2 sine omega cosine omega. So how do we solve that? Well, we go to the double angle identities, and we notice that this is the sine, the double angle sine identity right there. Okay, so we just plug that in here, and we get this. 1 equals sine of 2 omega. And we can solve that using the multi-angle techniques we've talked about earlier. Remember, omega needs to be between 2 pi and 0, okay, which means 2 omega is going to be between 4 pi and 0. Meaning, on our unit circle, the sine of some angle equals 1. That's only going to be right here at the top. So my two solutions are pi over 2 the first time you go around the circle, and the second time you go around the circle, you hit 5 pi over 2. So in other words, 2 omega equals pi over 2 and 5 pi over 2. That means omega equals pi over 4 and 5 pi over 4. Those are our solutions. You would have gotten the exact same thing if you had used the Pythagorean identity for cottage cheese up here at the beginning. This is just an alternate way to solve it. You don't always have a choice. Sometimes you will be kind of forced into using a double angle identity. This is just showing you when it's optional.